Hello everyone, this side Rahul Rupale, and this is a 11th video lecture about data science. And today's topic is logistic regression modeling. Now, discussing about logistic regression modeling is a introduction of a logistic regression. Firstly, is a classification, sigmoid function applications. Logistic regression predict the probability of a specific categories, and second one is a sigmoid function. Sigmoid functions transfer linear predictions into probabilities. Applications, it is used to various fields such as finance, healthcare, and marketing. Now moving forward and discussing about preparing the data for logistic regressions, data cleaning, feature engineering, data splitting, handling missing values, outliers, and inconsistencies. Feature engineering is created a new feature for existing ones on to improve model performance. Now, third one is the data splitting. Divided the data into training and the testing sets from model evaluations. Now, implementing logistic regressions in a Python is a libraries, model initializations, model training. Libraries important essential libraries like skit learning as a pandas. The second one is a model initialization, creating an instant of the logistic regressions model. Third one is the model training. Model training, the using the training data. Now, evolution of the logistic regression model: accuracy, precision, recall. The percentage of a correct classification instant, and the proportion of the correctly predictive positive instant, the proportions of actual positive instance correctly predicted. Now, interpreting the logistic recognized result. First is a coefficient, p values, or ratios. Interpret the coefficient to understand the implement of each functions. Determine the significance of a functions model. Calculate the odd ratios from each for each features. Now moving ahead, handling categories variables in a logistic regressions. Firstly is a one shot encoding, convert category variables into numerical ones. Second one is a dummy variable. It's a basically create dummy variable to represent each category. Third one is the label encoding, and assigned unique numerical labels to each categories. Now, conclusion and key takeaways is a logistic represent is a variable tools to predict the categories outcomes. Now, moving to some how to perform Poisson regressions and a Pythons as a particle guides. Now, what is the Poisson regressions? Counter data analysis. It models a relationship between the independent variables and dependent variables that are represented count, such as numbers, events occurring, or intents. Now, predicting count. It is a estimates the expected count of event given certain predictors variables taking into account the inherent randomness associating with the count data. Now, assumption of a Poisson regression. First is count data. Second was the independence. Third one is the homogeneity of variance. Count data is a dependent variable, must be count variable, representing the count of occurrence of events. Observations should be independent of each other, meaning the occurrence of an event in one's observation should not influence the occurrence in another. The variable of a count variable should be equal to its mean, uh, implying the spread of the data is consistent across different values of a predictor variable. Now, importing necessary libraries. Firstly is state models dot formula dot api. Second one panda. Third one is a numpy. Provide the necessary tools for the fitting and analyzing Poisson regression model. Pandas choose for data manipulations and analysis. NumPy provides support for mathematical operations on array and mathematics. Now, preparation of a data for Poisson's regressions. Firstly is load and clean, features engineering, split data. import the data, handling missing values, and ensuring the dependent variable is a count variable. Creating a new features from exiting ones of necessaries to improve model performance. Split data. Divided the data into training and testing sets for the models training and evolutions. Now fitting the poison regression model. Firstly is the sm.glm bracket. Use states model libraries to fit the model. Second is the formula. Specify dependence and independence variable. Third one is the families. The set families arguments to poison to use the poison distributions. Fourth one is the fit. The fit model to the training data. Interpreting the model's resultant. Firstly is model summary, coefficient, evaluation matrix. Now applications and a particular example: customer order 10K, traffic accident 500, and social media engagement is 1 million. This is all about logistic regression model, and hope you enjoying and like the video. Thank you for watching.